my name is Laura and we are Group C. We will be talking about Segway's robotic mobile platforms. The presentation mainly focuses on what is a robotic mobile platform and the different types of robotic mobile platforms available in the market. So to start up with a little bit of background information, the inventor of Segway is a man called Dean Kamen, who unveiled his first product, the personal transporter, in 2001 on a show called Good Morning America. The personal transporter is the first electric scooter that is able to balance and maneuver in the way that it does. In 2009, the company was acquired by a man named James Heselden, who renewed the focus of the company towards the robotic mobile platforms. What is unique about these platforms is that you're able to personalize them into other robots with a variety of abilities. By 2012, this product was a market leader, and it expanded to all parts of Europe. Its latest model is called Arti, which is still a prototype but includes all of the latest innovations on RMPs. What is innovative about the RMP model is the way that the company was able to incorporate all kinds of technologies. For example, dynamic stabilization, which enables balancing the platform, and also it includes a unique way on maneuvering it. It also includes electric propulsion, which provides accurate turning and a smooth ride. It also includes software-based approach to traction control and braking, and advanced sensoring, user interfaces, and digital dashboards. All of these technologies allows the consumer to further develop their projects and personalize them in the way that they need. Now Kenneth will further explain the ways in which the RMPs can be used in a variety of ways.
The K5 is Knightscope's autonomous robot that helps in crime prediction and prevention. On October 31st, 2013, they announced that they will be using Segway's RMP 220. They chose this mobile platform because of its dynamic stability and power for the K5 sensors and hardware that it will be carrying around. They also chose this mobile platform for its high maneuverability, zero turning radius, and the fact that it offers a human height point of view. And the K5 will need this when navigating through crowded areas and to avoid obstacles that may hinder its path. The K5 houses a wide variety of sensors, depending on whether it will be used during the night or the day. Some of these sensors include omnidirectional cameras, an ambient noise microphone, thermal imaging, and optical character recognition. Moving on to the next project, the DRS, Unmanned Ground Vehicle, or UGV. This project was a collaborative effort between DRS Sustainment Systems Incorporated, Segway, 5D Robotics, and they competed in the Joint Improvised Explosive Device Defeat Organization, and they won second place in their Endurance Challenge on June 22nd, 2012. This project was a project to design a robot that will help lighten the load of soldiers. They chose the RMP 440 LE due to its four-wheel drive capabilities and its all-terrain wheels. And the RMP 440 is equipped to carry more than 200 pounds of critical equipment, including soldiers' packs, sandbags, food and water, and the 5D Follow Me technology, which allows the robot to follow the soldiers and react to their movements. Overall, the soldiers said that the robot was able to keep up very well, that it was easy to understand, natural to use, and they appreciated the fact that the robot was able to carry a lot of their heavy equipment. Moving on to the final project, the Home Exploring Robot Butler, which was created by Carnegie Mellon University's School of Computer Science. This robot was used for research and development, particularly in the use of computer algorithms and software which allows robots to complete intricate manipulation tasks, such as splitting an Oreo cookie in two. The Herb was mounted on an older model of Segway's RMP 220, the RMP 200. Though it's an older model, it still provides the dynamic stability, high maneuverability, and zero turning radius that will be needed when Herb is navigating throughout the house. Ultimately, CMU wants to develop this robot to become the best robotic butler that will help in the homes of those that need assistance. Now, Iti will talk about current Segway designs.
Depending on the type of use, the user can pick the best RMP. The following few are the discontinued RMPs. The first three are the statically stable RMPs. The RMP 400 is useful for challenging landscape. It can take a speed of 80 miles per hour while carrying a 400-pound load. RMP 50 comparatively only weighs 70 pounds and can only take a speed of 4 miles per hour. Therefore, it's useful for flat surfaces. RMP 50 XL is durable, compact, and highly maneuverable. It's useful for competitions, teaching environments, and service applications. With a weight of just 95 pounds, it can take a speed of 10 miles per hour. The following few are the dynamically stable RMPs. RMP 100 is best for indoor use. With a weight of 125 pounds, it can carry 150 pounds. RMP 200 ATV is best for mobile robot researchers. It is useful for robot soccer, human-robot interactions, and path planning. The RMP 400 and RMP 50 Omni are made of macadam wheels which allow them to turn sideways. They have lithium-ion battery packs. The RMP 50 Omni can only take a speed of 2 miles per hour with a range of 2 to 3 miles and a payload of 150 pounds. However, the RMP 400 Omni can take a speed of 7 miles per hour with a 4 to 6 mile range and a 400-pound payload. The following are the current designs which are still available in the market. The RMP 220 is a self-balancing platform. It's a base platform for the Knightscope's K5 autonomous data machine, which predicts and prevents crime. RMP 440 LE and SE are four-wheeled platforms. They can take a payload of a maximum of 400 pounds and take a speed of 18 miles per hour, maximum forward and backward speed. The RMP 440 LE stands for Large Electronics Enclosure. It has a recharge time of 8 hours. The RMP 440 SE stands for Small Electronic Enclosure. It has a recharge time of 2 hours. The operating temperature ranges for the RMPs vary from 12 degrees Fahrenheit to 122 degrees Fahrenheit, with a smaller range for some others. Also, the Segway company provides softwares for the users to check and test the functionality of their RMPs. Now, Laura is going to introduce you to the environmental impacts of RMPs.
The RMP models are designed to be environmentally friendly by reducing greenhouse gas output and reducing consumption of imported fossil fuels. As mentioned before, the RMP models are powered by custom-designed phosphate-based lithium-ion batteries, which allow the platforms to have zero emissions during operation. This also allows for the RMP to consume an average of 0.052 kilowatt-hour per mile, creating 0.081 pounds of CO2. This is 14 times less greenhouse gas emissions than any American fuel-powered mobile platform. The RMP models are also energy efficient, which reduces operating costs, reduces energy demand, and dependence of oil. It is estimated that the RMP models consume 1.04 kilowatt-hour of electricity in order to be fully charged, which lasts 16 to 24 miles. This is 3 times more efficient than the average American fuel-powered mobile platform. Now Kenneth will talk about the future developments of Segway's RMP.
Segway's latest prototype, the Arti, earned its name from its articulated steering. The main focus of this design is its joint that allows for 2 degrees of freedom. This joint allows for roll and yaw rotation, which allows the Arti to maintain wheel contact with the ground at all times. Now designers don't have to worry about the torque needed to overcome the frictional forces. Rather, the payload is directly related to the structural limits of the gearboxes themselves. As of today, the Arti has proven to run the quietest and the longest with the heaviest payload. The Arti weighs about 300 pounds and it can support a payload of 600 pounds, and it can attain a maximum speed of 18 miles per hour. In conclusion, Segway's line of RMPs are continually being developed and improved. They further research, help society, and ease transportation. These RMPs are environmentally friendly due to the fact that they use lithium-ion batteries instead of consuming fossil fuels. And Segway designs these RMPs with simplicity in mind to help the consumer manage and personalize their robots to their specific needs.